Welcome to another episode of Shop Happenings. This is an exciting day for us. Today we're getting a visitor, and it's going to be revolving around this tool right here, which I'm about to present to you. It's pretty cool. We found out about that tool through Matt Urbach. Matt is a machining teacher at Steamwood High School in Illinois. Matt's one of the 10 schools, including us, who are building prosthetic leg parts for people in Latin America. Currently we're working on this part. This is only half done, but we're having some difficulties getting some deburring done in the inside of these holes in here. We did have a student bring in a tool from where she's working. She's letting us borrow this for a little bit to try it out. This is a Noga tool, and as you can see, it's an RC1000. It's a reversible mini countersink, and this is really cool. The way the tool works is that we can push the button, which makes the cutter go into the cutter itself or into the tool itself. We drop this into the hole, release this, and then as we pull up gently, we can turn this back and forth, and it will make a nice countersink for us, and it does deburr the inside of that hole. Now, because we have hundreds of these holes to do, because we're making more than one of these parts, that's becoming very time consuming for us. So I talked to Matt on the phone, and Matt told us about this Cogsdill Burraway tool. And this is really cool. So I contacted the company. I first spoke with a Myron Griffin. Mr. Griffin is going to come here today and show us how to use this tool. Myron got me in touch with the Vice President of Sales and Marketing, Amori West. And Mr. West was very gracious in donating 2 of these tools to us. This happens to be the smaller of the two. The larger of the tools in our machine that is going to be used today that Mr. Griffin is going to help us with. But this is the smaller of the 2 tools, and as you can see, it's relatively simple looking. This is, again, the Cogsdill Burraway tool, and this is the cutter that goes in this tool, and there's already a cutter in it. You can see it right here. What this cutter does is that it's spring loaded, and this happens to be for the smaller of the hole, so it happens to be for these. And the way this works is this runs into the hole. It is spring loaded, so it'll run while it's spinning. It'll bounce into that hole. While it's spinning, it'll twist around in circles, deburring the hole, and then as it comes out, it's spring loaded and will release. They've sent us, Cogsdill did, they sent us all the technical specifications for this. They gave us a whole bunch of sheets. This happens to be the tool adjustment and operating recommendations. Inside here they have another part. I'm thinking about getting this for my house. This is an amazing tool, and I can't wait to see it work. But if I flip some pages here, they also sent us these speeds and feeds for this tool, which is really exciting. They are right here in this chart. Real simple to use. We've already calculated these in. We've got that other tool into our machine. We've got a part that's all chucked up, and we're going to give this a whirl today to see how well this works. So again, what we tried doing is we tried using this Noga tool, which actually worked really well. It's just time consuming and a lot of labor intensive. We have tried using this tool, which is just a regular deburring tool, to get inside the hole. But again, to do this motion over and over and over again, it is effective, but it takes time. What Matt Urbach and Mr. West and Mr. Griffin suggested is that we go with this Burraway tool, and we can put this right into our CNC machine. This will allow us to make this part of our operation, so when this part comes out of the machine, it'll be done. We don't have to deburr a thing. This will do it for us. So what's nice is we're increasing our effectiveness, we're increasing our accuracy, and this tool should make our lives a lot easier in the long run for other projects. So I hope you enjoy this video. It's going to be very informative, I hope, and I hope you enjoy it. Stay tuned for more. Yesterday, Myron Griffin came to our school and helped us calibrate the tool that Cogsdill gave us. This is the Burraway tool I showed you yesterday. What Mr. Griffin did is that he verified our speeds and feeds were correct. He made sure that we were in a tool holder that was adequate for our operation. In this case, we're using a Parlic Cat 40 tool holder, which fits into our OKK VM4. The reason we have to do this is at some point during the leg build process, so this is our leg, we have to drill a bunch of holes in this piece, which makes this leg adjustable so that it can be fit to someone before we meet them. To do that, the inner piece, and this is a piece we've already finished, has to slide through the outer piece, or the inner piece here has to slide through this piece with all the holes in it, and the burrs on the inside have to be removed because this has to be a really nice sliding fit. So far we're doing a great job with these. I have a young lady that's just kicking butt on these, and I'm so impressed with what she's doing. So at first we had these really awful burrs. I hope you can see them on camera. They're pretty rough shape here. Those were happening on the inside of our hole as well. This is a piece we did yesterday with our Cogsdill Burraway tool, and I'm really impressed with the finish. We pulled it out of the machine. I can run my finger over this and no problem at all. We have to deburr these separately with a different tool because this is a different hole diameter. We don't have clearance on our vise to come through with our deburr tool. So this will be a different operation to hit these holes. This is going to work well for us. The process we used initially to clean up these burrs is we used a boring bar. And we put this in our lathe. Did a great job. It deburred the holes, did everything great. The problem is that the outside of this extrusion and the inside are not concentric, or at least within the tolerance that we need. And we were concerned that if we got them concentric, that our wall thickness, and this is Cat 42, Schedule 42, we were concerned that our thickness wouldn't be durable enough to handle the stresses of a prosthetic leg, and we would make this diameter the wrong size so that it wouldn't fit into the upper part of the leg, which is here. So this has to fit no matter what into there with a certain tolerance, of course. If we made it smaller, it wouldn't fit, and then the leg wouldn't be durable enough to withstand the test of time. Another school's doing these. Remember, we are one of 10 schools working on this project nationwide, and this is most of it, not all, but most is funded by the Harbor Freight Tools for Schools program. We did get a grant for that, and we're still working on our legs to make this a project that people can use throughout the world. So as I said, we needed to deburr holes. We tried a boring bar. That didn't work. We do have to have a very good tolerance, as you can see, and this Cogsdill Burraway tool that the process engineer from Cogsdill came down and helped us with yesterday, he was awesome. He looked over our process, gave us some good suggestions. We made some changes, and we're going to continue to make changes today and into the future to make this project more efficient and better. Stay tuned for more in this video. You'll see some more of the stuff that we're doing. Thanks for watching. Here we are at our OKK VM4. If we walk up to our machine, we're going to see two pins. These two pins have been put in by a student. What they're going to do is allow us to index our part. These two pins have been specifically made to be pressed into these vise jaws. There's two matching pins back here. These happen to be a larger diameter. And the reason for that is our part has gone through once already. So we've machined this part to length, and we've popped some holes in this. Notice these holes are larger than those holes. So what this does is our vise jaw allows us to put this part in so that these holes line up here, and they just slide on. And it's a really snug fit because it has to be, because it indexes our part. And then this moving vise jaw will get moved in. It'll engage the larger holes, and that will allow our vise to be tightened down. It indexes our part not only this way, but it also indexes our part this way. So we have both our rotational, or our A-axis is taken care of, and we also have our X-axis taken care of. So that way this part's indexed correctly, so that the holes that we put in here will be perpendicular to the holes that are put in here, and they will be offset the correct distance. Here I am back in front of the OKK VM4, and this is a part that just came out of our machine. This is a part that the Cogsdill Burraway tool was used on. I'm hoping you can see that in the video. You can see this little nub that sticks out here. That's the part that's carbide that actually does the cutting that creates the chamfer and gets rid of our burr. As you can see, I can run my hand over this with no flaws at all. There's no burrs at all. Like I said, this has not been touched other than the OKK. Once the larger holes were deburred, which are these holes, as you can see, these are larger than the other holes. This is a 1/4 inch hole. This is done with an O-size drill bit. When the Cogsdill deburr tool went in, it chamfered the outside. That little spring-loaded section is able to fall through the hole. Once it falls through the hole, as it comes back out, it also chamfers the inside and deburrs the inside. So as you can see, take my finger in here, no sharp edges. Absolutely amazing tool. This is the smaller of the Cogsdill deburr tools that we received. This one we actually put into a hand drill. We were going to set it up into one of our K3 mills. We didn't do that because the setup time was going to exceed how long it was going to take to put this in a drill. So we threw this in a drill. This ran into the small holes. It deburred the outside of the things that we already had done. We had a bunch of these done. So it deburred that. It popped on the inside of the hole, and you can see on the inside it'll deburr as it spins around in here. It deburred the inside of the hole, and it pops back out. And we did that with just a regular hand drill. We used a cordless drill, sped it at a relatively low speed, gently pushed it in, pulled it back out. Worked absolutely wonderful. Please check out the link to Cogsdill and their Burraway tool in the description. These are worth every penny. The amount of time it saved us was absolutely astronomical. The reason these have to be so good is when we're all done, we're going to have a sliding sleeve in here. So this is a piece that's cut on our CNC lathe. This part came out really good. I have a student working on this. We'll get some footage of that as well. This is moving in and out of here, and this will have 2 holes drilled in it so that they will index themselves with the holes in this. And so far we're about 6 or 8 thousandths small, so this slides really nice. This is absolutely incredible. There's no play in this, and somebody will be able to use this leg for a long, long time.